Trying to write my comprehensive exam proposal in 24 hours. That's the state of things.
Yeah. Is it when are your comps?
We're gonna try to plan it for end of May, early June.
Okay. I'm pretty sure I gave, this is not good advice, but I'm pretty sure I gave my committee the proposal like a week before.
Yeah, like online they say ideally 4 weeks and not less than 2 weeks. So
okay. I may have given them 2 weeks then.
Yeah. So, well, I'm gonna try at least like if I finish it today and Doug's wanted to take a look at it, so it's gonna already be next week. So yeah. I think the time's gonna, even if we do just one round of review, that's gonna take time's gonna fly quickly.
Yeah, fair enough.
Yeah. And they're probably going to spend 10 minutes on it anyways.
Yeah.
Yeah, make sure your intro is good and that your figures and figure captions are pretty, and you'll be okay.
You just fill in with like the random text generator, you know?
I'm sure somebody's written a thesis proposer neural net.
Yeah, I think it's already been done. Yeah, like they submit a paper written by an AI, like that trained on millions of papers. Yeah, I saw that somewhere.
Yeah. Cool. Okay, well, I'll just maybe like flip to the notes. Leon was going to try and join us today, but I got an email from him saying he might not be able to. So we'll see. But in terms of quick updates, I'm sure most of you probably saw on Slack that Dieter released the multi-grid solver that he's been working on, which is really exciting. Yeah, so I haven't looked at it yet, but I think he's included some examples that compare with Paradiso, or at least the version of Paradiso that's distributed with MKL, which is out of date with the current release of Paradiso. But it's the easier one to install. So yeah, so totally worth checking it out.
Is that in discretized or in EMPI mode?
I dropped the link into the notes, but it's under the EMPyMod organization, like GitHub organization. But he does make use of discretized. So I think all of the meshing, and this is, well, we can take a look, but I believe that all of the meshing that he's done is using discretize.
Okay.
Right now, it's tailored towards the tensor mesh. But because it's built like on top of discretize, if there's people who are motivated to have this up and running for the tree mesh, then I think that that's totally possible, and we could talk to him about like how we might abstract some of what he did to be able to work across mesh types, which would be really cool.
Okay, cool.
Yeah, the speed up is pretty impressive. Eh?
Yeah. So he's gonna give us a presentation in 2 weeks. So we'll move the SimPEG meeting on the 14th, if this is okay with everyone, to 9 a.m. because he's in the Netherlands, which is a 9-hour time difference. So this would be at like 6 p.m. for him.
Yeah.
Because I think right now it's like 3 in the morning or something there, so it's not an ideal time. Yeah. So as long as that works for everyone, then we can plan for that. Cool. Are there any other updates on your guys' end, like quick things you just want to sort of bring up, put on the radar?
I've been mostly on GIF2 the past few weeks, so SimPEG development went a bit under the radar for me, but coming back.
Cool.
I started looking into the image recognition part of thing, finished the thesis. I put a picture in the doc.
Yeah, I'm just looking at that. Do you want to tell us a bit about it?
Well, yeah, the issue is that we try to rotate the objective function, right? So that we're kind of like going parallel to edges.
Yeah.
But then we don't want to have to like specify points. We don't have to do it manually.
Yeah.
Then it just becomes like a pattern matching, like an image pattern matching to figure out like what's the principal moment of the image. So if let's say your density is changing out in one direction, you just want to align with it. Just looking at your algorithms like the skeleton of scikit-learn to be able to switch it from like a raster to just a vector line, and then do a principal moment on it. So, anyway, it's actually pretty fun.
That's really cool.
Yeah.
So it's picking up on are the red lines basically like following the maximum?
Yeah, that's right. So you basically simplify it into like just zeros and ones, right? Your image into zeros and ones. And then after this, it's just a matter of like computing like the eigenvector of that image, and then that gives you the principal axis of how pixels are kind of oriented generally. And then you just do this, you just sweep through the image like this, figure out like axes.
What's converted to zeros and ones?
It's scikit-learn as a skeleton.
Okay.
So first it does thresholds, it thresholds everything, and then it finds the middle of contours.
Okay.
Yeah, it's just like basically the edges, like the middle of all the maxes.
It's like is that like a level set basically?
No, it's kind of like a derivative thing. They kind of dissolve it from the maximums, and they kind of like go towards the center. So skeleton. Skeleton-less. Make the horse from the horse. I'll put it on stack for you to.
That would be great.
Mm-hmm.
Have you checked out scikit-image at all? Oh yeah, you are in scikit-image. Okay.
Yeah.
Cool.
Took me a while to find something that would do that, but that works pretty well.
Oh, I see. So it's basically doing. Oh, that's interesting. It's not edge detection. It's actually.
The middle, yeah, the maxes. Yeah.
I see. Oh, that's cool.
And then after this, on top of the skeleton, then you just do a principal moment. So like it's much easier to deal with the skeleton of the image than the contours.
Yeah.
After this, you can find what's the orientation of those, so that you can get a vector, right? Instead of setting back rasters.
Yeah. So then, like, is the workflow idea that you start, like, you do sort of a blind inversion, and then you find the skeleton with this, and then re-invert using the new regularization?
Exactly. And then that's good for horizontal, right? Because we already have good edge definitions in 2D plan view.
Yeah.
But after this, for the dip, then you just do a learning process where you do a sweep through all the angles, and then you find kind of like the best matching dip. You do the same thing after this in vertical section. You're basically learning.
Will it be super expensive to do it at each iteration instead of running a free inversion, then doing the thing and then running a free inversion? That you can just like force it at each iteration? Like you basically change your regularization at each iteration.
Yeah, you can't restart it too far, right? Because it's kind of it's a nonlinear process. You kind of need to restart. You don't have to restart from like high beta.
No.
Once you find your optimal point, then you restart from there. Right? Yeah. So I thought that was pretty cool. Start learning, right? Learning the model space.
That's really cool. Thanks for sharing that. And so is this sort of going into SimPEG, or do you see this more as like a piece that you bring in through a notebook or?
Yeah.
Yeah.
I think so. Yeah. I mean, it could be nice to wrap the image moment, because it took me a while to find it online.
Yeah.
Kind of buried. There was like 1 or 2 posts on like Stack Overflow and stuff, but since the processing is done on a 2D mesh, then I think it would be fair to just put it somewhere in the examples of SimPEG.
Yeah, that's fair.
Mm-hmm.
Can you use that skeleton thing for 3D mesh?
I think we can. Yeah, it's an ND. It's an ND. I wrote an NDR.
Okay.
Yeah.
Cool.
don't know how it would look though. I guess you would make a sheet.
Yeah.
You make a sheet. It would be interesting. It's a good point.
I know I look at some point that's like it's an H2, but for remote segmentation, but I just ended up building my own algorithm because I was looking for something very specific.
All right. Yeah. Piece some stuff together.
Yeah.
That's cool. I've been working a little bit more on the simulation side of things. I didn't get quite as far as I was hoping to. I spent a bunch of time working through the fast AI tutorials. I don't know if you've seen them. If you're looking to like understand neural nets, it's a really solid set of tutorials. And they've got like videos and notebooks and things like that. I can post a link.
Fast.ai.
Yeah. Yeah, so I went through the first one, which is practical deep learning for coders. And it's nice because they build it all on top of PyTorch. So they've actually written a library called Fast AI that like sits on top of PyTorch that simplifies a few things. But you can basically sort of learn from what they did to then, if you want to go lower level and sort of build your own networks and things like that, you can sort of follow what they did and learn some PyTorch. So.
Right on.
Yeah, so it's pretty slick. But I might, if you guys are game, give you maybe just like a bit of an overview of some of the thought process with the simulation class.
Go for it.
Yeah, sure.
Okay, I'm gonna try sharing my screen here. You can see that we're in the infinite loop.
Infinite loop.
Excellent. Okay, so what I have here is a notebook where I've been looking at kind of refactoring basically like the base layers of SimPEG, mostly the problem and survey, but then as I go through trying to do a bit of light cleanup in several places. So the first thing to notice is that trying to switch over to using lowercase for importing modules. What we can do, like we'll still allow the uppercase imports for at least the next release, maybe 2, just so that it doesn't like completely become a real pain to switch over. We can sort of phase that through. But as you're writing new code, it might actually be a nice idea to start doing like something like this. Where you import the capital name as a lowercase name, just so that like basically all of your code in the future is sort of written with these naming conventions already in place. So then when we actually make the switch, all you do is delete that, basically. So not required, but that'll help like with the transition a bit. But basically the way I'm thinking about sort of trying to organize things and have the simulation interact is first of all, really trim down what the survey class has. So at this point in time, the survey should only really have the data and then the sources and receivers. It doesn't know how to compute data, anything like that. It doesn't really do any computation. It's just a container for like the survey geometry and the data. So in this case, the simulation, like much of the API will be very similar to the problem class. So like it takes the mesh, it knows what mappings you're going to use. In this case, I was just looking at like the exponential sinusoid. So it also has things like the number of kernels and whatever, so that you can set that up. And then the simulation knows how to it knows how to compute data, so it knows how to do predicted data and the fields. So instead of having like dpred be on the survey, now all of the things are like all the calculation pieces live on the simulation. And feel free to interrupt me if you have questions. I can't see you, so it's
that makes sense.
Yeah.
Okay. One of the things that I think might be kind of interesting. So in this case, here, what I've been thinking about for like making synthetic data, I think the idea of the data class is quite handy, and so we're trying to, or like as I'm kind of rewriting some of this, think about how we want to use the data class. So in this case, this data object is actually a synthetic data object, which is kind of nice. So it actually then has, I'll show you a few things on there. So it has its clean data as well as deobs. So if you want to run sort of playing around with different noise models or things like that and still always be able to plot your clean data, it will always be able to do that. So it keeps track of it for you. Whereas a normal data object obviously won't have the dclean because we don't know what that is. It also has the noise model. So it has a noise floor, which can be a vector, which is the same length as the data, as well as the standard deviation, which again can be a vector the same length as the data. And I'm keeping, you can also see like the EPS and the STD for now. If we actually call that, if we actually call that and I fix this bug in the code, it will provide a warning that just says we are trying to use noise floor instead, rather than EPS, rather than that shorthand. So it'll still return once I fix this, but trying to shift to like a little bit more explicit naming.
What's the link between survey and data then?
So now, if we look at simulation, or okay, so if we have the data, it will have a survey attached to it. So it knows, where its sources and receivers and such are. But if we look at the survey, or sorry, so the simulation now holds the survey. Oops. It does not have data. It will only have a source list. So actually, I can pull up the code. That might be easier. Can you still see that?
Yes, here.
Or like, can you see the code?
Yeah, we can see the code.
Yeah. Let me do this. Okay. So, and is it big enough?
Yeah.
Okay. So if we look now, this is sort of the same source receiver code. If we look at the base survey, it's quite lightweight. So it has the source list, which knows about its receiver. It knows how to get a source index given the source. So it knows where in the list each source is. And it knows how many data it has and how many sources it has. That's basically it. So it's quite trimmed down. I've left dpred for now so that like it gives you a sensical error, but it won't actually, it doesn't do anything.
And so what's the advantage of moving data out of this?
Basically just to simplify where the data is living. So rather than having a bunch of stuff tacked onto the survey object, really the data needs to have a survey that describes it. So the data is sort of the first class citizen in that sense. So if we look at like the data class, for example, so it has the observed data, standard deviation, noise floor, and then it basically, the survey is what gives meaning basically to each data point.
Okay.
Does that make sense?
Is that going to make it easier to save and serialize these objects? Is that the part of the thought here, or?
Yeah, that'll certainly be a byproduct of this. It's also just a question of like where things live, because right now the way that the data, or like the one thing that I really think is unclear is where the standard deviation and noise floor are set in the current SimPEG code.
Yeah. Ran into that issue a
Yeah,
while.
I mean, it was unclear whether you set it on the data misfit or you set it on, like we didn't actually have a data object.
Yeah.
So you would set it on the survey, which is kind of weird. So this hopefully cleans up like where those uncertainties are set. And then the data misfit, actually right now, and this is maybe a question that would be worth chatting about here. So right now the uncertainties are found just based on the data. So if you want to overwrite the W, that's something that you can do. But you would actually have to overwrite like the weight matrix. We could also make it possible to overwrite just the diagonal if you want to set like different weights than what's sort of on the data object. I don't know what your thoughts are on that.
I think it makes sense to have it defined kind of in one spot and have everything kind of pull from that one spot instead of having it set in a whole bunch of different spots.
Yeah.
Then it's easier to get into trouble. Yeah.
Okay.
I don't know. I'm not sure. So you're just saying that we're not going to have a misfit function anymore. It'll just go pull the diagonal straight from the data. Is that what you're saying?
No, we'll still have a misfit function. So we'll still have like the base data misfit or the L2 data misfit. But right now, like the way that most people, or the way that most uncertainties are being set are by basically creating the W matrix, which is fine, and you can still continue to do that. But we'll make it easier for, like, if you've defined sensible uncertainties on your data, then here, like, it'll just pull the uncertainty, and then we'll do 1 over that for the diagonal. So here, if we actually look at what the uncertainty is, it computes the standard deviation times the absolute value of the data, and then we add the noise floor. So because I set it to 0, and then we just add like that percentage error plus the noise floor. And then that is what is used by default in the data misfit.
Yeah.
Okay.
We'll have to see it in action, I guess.
Yeah, I mean, the example that I have like sort of shows it, but not really. So I don't want to spend like too much time on this at this point, I don't think. Yeah, but are there other sort of like general comments or ideas that like you think we should prioritize sort of as working through this?
Can you just, I don't understand the idea, because we're going to create a simulation that will require a survey.
Mm-hmm.
All right?
Yeah.
But then survey is kind of a second class of, it's kind of a class of data. So what's the, I don't understand, because the survey sounds to be that is becoming like a second level thing to both simulation and data, right?
Yeah, so it's sort of like in the current, so in the way that this is implemented right now, you could still run a forward simulation without ever creating a data object, if that makes sense. You can still create a survey object independently. So the survey object basically in its lightweight form has just sources and receivers, and that's it.
And then the data that you forward modeled would be associated with the simulation. It doesn't automatically get put into a data object. It's part of the simulation object.
So, okay, when you say data, are you saying predicted data or are you saying observed data?
Well, so if you're forward modeling, it'd be predicted data, yeah.
Yeah, so if you're forward modeling and we just ask for predicted data, right now you get back just a vector. And so that's not actually a data object. When we create a data object would just be if we're actually asking to like basically create something that we want to then invert on. So the example that I gave here was if you create synthetic data, that then creates a data object and associates the survey from the simulation to that object. It doesn't copy it or anything, so we're not like creating multiple surveys that are floating around. It just then points to that survey and says, this is how like you make sense of this vector of numbers. Does that answer your question?
Okay, well, what is going to happen if we load data from a file? So now you're going to have a survey. The survey lives where?
So if you actually have the data file, what we would do is then create a data object which has a survey attached to it. So if you wanted to then create a simulation off of this, you would just pass the simulation data.survey.
So basically, when you load the data file, it's going to produce both a survey and a data object.
Yeah.
And
Like-
then they're going to be linked. Yeah.
Which is basically what happens right now, right? Like you create a survey and then you probably create a vector of numbers. So in this case, we just keep them in one container.
Yeah, that's fair.
Yeah.
Yeah, sure.
Okay, so what I'm gonna keep plugging away at is try and get this into either the frequency or the time domain code. I don't think it matters too much which one we go for first. To then sort of have an example where we've got a bit more involved physics rather than just the linear problem. And then I chatted with John. He is in town, so we met up over the weekend. And got connected. And so he's interested in diving into the MT or the natural source codes a bit. So I think like potentially the way to then propagate these changes throughout the code base is like different people can pick up different components. So like Dom, if you want to inject this into the potential fields codes, like I'm happy we can just be on a call for an hour or something and refactor the code together. And then same thing, hopefully with John, is to get him maybe doing the MT code. And then if there's other pieces that people are interested in, we can maybe just create like a running issue or something like that, or the pull request, just to make sure that like, we get lots of people involved so that this isn't like a foreign idea. Is hopefully, we get the issues and kinks worked out pretty quickly.
Mm-hmm. Sounds good.
Excellent. Cool. That's basically all I have. Do you guys have anything else you want to chat through, or we can call it a day?
Yeah, I think so, yeah. We're all going to go back to our papers.
Fair enough. All right. I am not going to be able to make 2 p.m. next week. So we can either move if there's enough things to go over, or we can just postpone to the following week, or you guys can have the meeting, and I can always catch up afterwards. So
Let's reassess Monday.
Yeah.
I'm leaving for South Africa like on the Thursday, so it's probably gonna be nuts next week. So yeah, maybe postpone is okay too.
what's bringing you to South Africa?
Training for Rio and Anglo.
Yeah.
I'm gonna give a 15-minute talk at the Saga, their geological association.
Yeah.
So yeah, let's prepare for that.
Cool.
I'm just gonna grab Doug's talks and then dice it up.
Yeah. Excellent. Well, and hopefully a bit of time to play tourist while you're there. It's a long ways to go.
Not really, it's just a week.
Yeah.
Just be there for a week, so it's quick.
All right. Sounds good.
All right. Have a good week.
You too, guys. Good to see you.
We'll see you, Lindsay.